Okay, let's now talk about motion in when something's moving in a circle. By motion, we mean what's happening. We mean what's happening in time. What's happening in time. So whenever we look at a motion, we look at where something is at some point in time and then where it is at some other point in time. So for instance, in a circle, if something's moving in a circle, so something moving in a counterclockwise way, so this direction. So it's over here at time t, and maybe it's over here at some other time, a little bit later time, t plus delta t. So motion is about quantifying what's happening into the distance and whether these distances are covered in a uniform way. So one of the measures of the motion is the speed. So we look at the distance. So for the speed, we're going to look at this distance. And this distance is arc distance. Let's call this point A and this point B. So the arc distance is AB, which we can write as delta S, because it's happening over an interval of time, that's delta t. And so we can have a measure of how fast this is moving. So if somebody asks me a question of how fast it's moving, I just go and say measure this distance and measure this time, and you can divide the distance over time to tell how fast something is going. So this will give me speed. You might say it will give me average speed. And if this interval is very tiny, this average speed will be instantaneous speed around here. But we just, let's look at a average speed. That's going to be the distance this, or over how much time. And we can, you can see that if this was a meter, if this is meter and this is second, then the unit of this will be, as you expect, meter over second. So that will be the units. The letter we're going to use the same letter as before. We're going to denote by letter V. So one way to kind of get a feel for it is say something is moving in a circle, has a radius 2 meter, and it went from A, and it went all the way around in the circle back to A. It went and we came back to A, back to A. So that means it went one circumference. And then I measure the time. Time, say, is 5 seconds. You can say, well, I don't know whether it was changing speed or not, but I can say what was the average speed. Average speed will be 2 pi, because I went one circumference, 2 pi times the distance and the amount of time it took. Let's call it capital letter T for this time. And so it's going to be 2 pi times 2 meter over 5 seconds. So you can see that I have 4 pi, 4/5 of a pi meter per second. You can use calculator and actually get a numerical value, approximate numerical value of it, but I'll just leave it at this. So this tells me average speed. Now, if I measured, like, say the same experiment, but I start with A, and I came back to A, but it was too fast, and so I let it happen many times. So suppose A back to A, let's have 10 times. So that means I went, that will be 10 times 2 pi r will be the distance. And say the total time was, say this was 2 meters here again, and total time was, say 10, maybe let's put it 30 seconds. It went that and 30 seconds. This time the average speed will be, I have 10 times 2 pi r. That's the distance I went. It took me 30 seconds. So it's going to be 2 times 2 meters. So 2 times 2, 4. And this cancels that. So this is 4 over 3 pi meter per second. So you really have to know how much distance you have gone, if you've gone many times over, and how you might say, well, how about if something is going very slow? I measure only a few degrees. That's also so it's a circular path. Now it's not going the whole circle. Suppose I go to A, from A I go to B, which is only 15 degrees. So I gone only 15 degrees. So I need to figure out the distance here, how much distance I went. Well, if this is r and this is theta, then the distance is theta times r. But this has to be done in radian. So I got to do 15 degrees in radian will be 15 degrees times pi over 180. So I need to kind of make this 30 degrees is pi over 6. So this will be pi over 12. So this is pi over 12 radian. And if the r is still 2 meter, then s will be pi over 12 times 2 is pi over 6 meters. Now how much time it took to do this? Say time took, maybe it took only 2 seconds. Then we'll have a speed, average speed will be, how much distance I went that much distance, it took this much time, pi over 6 meter, and it took 2 seconds. So this is pi over 12 meter per second. Okay, so that's how we use speed. However, there's another way to talk about speed when something is moving in a circle, and that's using the angle. So if let's see, same diagram, right? So I'm going to have a circle with a center, and I'm at A at time t, and I'm at B at time t plus delta t. So it's I'm actually in that direction at time t, and in that direction another time. So the angle is, that's the angle I have moved in some way. In a sense, that's the angle. Of course, I've gone this distance. So how do we talk about the angle at which I am rotating? Maybe this line is rotating. So that angle will be arc angle. And let's call that delta theta. So that much angle I did in time t to delta t, so that's the amount of time it took, delta t. So therefore we can define delta theta over delta t a quantity which tells me the rotational at which this line from O to the where I am, how that line is rotating as I'm going on a circle. This is called angular speed. and sometimes people call it angular velocity, but we'll just use a angular speed, and it's denoted by Greek letter omega, and this looks like a round W, but this is like that. And so if you look at the units of angular speed, it is delta theta will be in radian, and this will be in second, so it's going to be radian per second. So the units omega is radian per second. Well, because the angle is related with how much I moved on the circle itself, we would expect angular speed to be related to angular velocity. So let's try to figure out that relationships. Delta S is delta theta times r. Since S equals theta r, I can write that. And so if I divide by delta t both sides, okay, so this will give me, the left side will give me V, and this is going to be omega times r. This is a very important relation. We'll use it in the future. Just an example will be, say I was going in a circle, and I went from this direction to that direction. Say this was a pi, that angle I moved it pi. Delta theta is pi radian, and maybe the delta t is 2 seconds, and say this radius is 2 meters. Then we can see what the omega is. Omega is going to be pi radian over 2 seconds, so this will be pi over 2 radian per second. So if I know this, and if I know the radius, I can figure out V is omega cross r, and omega times r, so omega is pi over 2 times 2 meters. So this is radian per second. You can see radian and meter are going to multiply and give me meter. And so that's going to be pi meter per second. So next time we're going to talk about how velocity, how to think about velocity. Now we know the speed and how the velocity may be changing. So the next is velocity and acceleration. Okay, so I'm going to stop here.